Good morning, guys. My name is Mark and I work for Adroit Technologies. I'm an engineer over here, and I'm going to talk to you guys specifically about the iQF PLC Modbus-TCP master setup. Okay, let's get going. So I'm going to do a quick introduction as to why we're doing this, also what Modbus is, and what is Modbus-TCP and why should you use it. I'll run through a quick scenario. I'll do setup with you guys, show you guys the wiring, which is pretty simple because it is Modbus-TCP. It is TCP Ethernet after all. And then I'll show you guys the iQF software setup as well. And then I'll show you a video where I will show you how to actually do it practically in real time. Okay. So guys, why did I do this seminar, or webinar should I say? The iQF PLC contains the ability to communicate on Modbus-TCP, but only as a slave. This webinar will show you how to do the setup of the PLC as a master. That's a Modbus-TCP master. As always, we'll use GXWorks 3 to do the setup. It's relatively quick and easy, and what makes it easy is that there's actually a function block which exists on this so that you can get it up and working. Okay, so what is Modbus? Modbus is an application layer messaging protocol positioned at level 7 of the OSI model that provides client-server, master-slave type communications between devices on different types of buses or networks. The industry serial de facto standard since 1979, Modbus continues to enable millions of automation devices to communicate. Today, support for the simple and elegant structure of Modbus continues to grow. The internet community can now access Modbus as a reserved system port 502 on the TCP IP stack. So Modbus is a request and reply protocol and offers services specified by functions. Okay, function code should I say. Now if we have a look at this slide, this actually shows you what the function codes are. On the left hand side of the screen you'll see what the actual code is. So for example, code 1 is coils, so you'll read coils from the PLC. Now coils are on and off coils that you set to the PLC. Function code 2 is you read in discrete inputs. That's physical inputs that are on the device. Okay. 3 is you read your holding registers. 4 you read input registers. Those would be, for example, stuff like your analog inputs, for example. 5 where you would write to a single coil, and 6 is where you would write to a single register. Okay. So what is TCP, Modbus-TCP? So TCP/IP is the common transport protocol of the internet and is actually a set of layered protocols providing a reliable data transport mechanism between machines. Ethernet has become the de facto standard of corporate enterprise networks, and so it comes as no surprise that it also became the de facto standard of factory networking. So basically, Ethernet has become the standard. It will become more of a standard as we move forward. The nice thing about Ethernet is it's a infrastructure type network. So you can set up a whole infrastructure and you can have different devices communicating on this. You can have PCs communicating on the same network, for example, sending emails and files across. And it can be on the same network as your factory as well, although this is not recommended at all. So combining a versatile, scalable and ubiquitous physical network with a universal networking standard, TCP/IP, and a vendor-neutral data representation gives a truly open, accessible network for the exchange of processed data. It is simple to implement for any device that supports TCP/IP sockets. Okay. So the quick scenario, what we want to do is we want to create a connection from one iQF to the other. The one iQF has to be the master. Okay, you need a master-slave configuration like I explained earlier, and the other one will be the slave. So the master will read and write device information to and from the slave. Okay. So what you need is 2 iQF PLCs, obviously, an Ethernet switch, Ethernet cables, and of course the GXWorks 3 engineering software. Okay. So the solution, you need to download a sample program from the Mitsubishi website. So step 1, go to that page. Okay. create a login profile, a profile with your own login details. Then once you've done that, you can log in with this new profile. Then you go to that specific page, you download the file and you extract the file. Okay. So the programming software, to set up the Modbus TCP, you have to set the parameters with GXWorks first. Okay. So let's quickly go through the parameter setup. So you open GXWorks 3, start a new project, select the project, and you'll go straight down to Ethernet ports. Okay. So once you're in Ethernet ports, you double click that and it will open the following page for you. Now you add your IP address there. Okay. I'm not going to go into details about IP addressing, it's quite complicated, but just add that IP address there for the start. And then you go to external device configuration. So once you've clicked there, you open this page, and once you get this page, you add the following into there. So you add a MALSEC connection and a MALSOFT connection and then an active connection. I'll show you guys a bit later on in the video why that's important. And then the IP address, that would be the IP address of the other PLC that you're connecting with. And it will always be on port 502. Okay, that's the standard port number for Modbus TCP. Okay, so once you've done that, you say close with reflecting setting, and you'll go back to this page, and then you click on the check button. If you have no error, then you click on the apply button and your network is basically set up. Okay, so what we want to do in this example is we want to read addresses 40,001 to 40,010, and we want to write to addresses 40,020 to 40,029. Okay, 400,029 should I rather say. Okay, so in order to do that, we need to, if you remember earlier I spoke about the function block that you need to extract. Well, once you've extracted it, you need to, you open up your program body, you add the actual function block to the user library, and you go to open that button, that page over there which says element selection. You register the library, and that file that you've actually extracted, you go and install that file, that MSLM file. That will contain all of those files for you. Okay, so that will contain all of those Modbus TCP libraries for you. Okay. First thing you do after you've created that is you always go and change your labels. And when I talk about labels, I mean that's your variables that you will change in the meantime. So under local, you're going to add all of these labels. Okay. And then you're going to go to your global labels, and you're just going to add those global labels. Okay. Once you've done that, you go to the program body. And under the program body, you will add the following. Now, I want to show you guys specifically there. It says 10 number of registers and 10 number of registers. That first 10, those are the number of registers that you want to read, and that 10 is the number of registers that you actually want to write to. Okay. So once you set that up, then you are going to go to number 19 over there. Number 19, that's the write registers that you want to write to. So when previously I said you want to write to 40,020, that's where you go and say that's the register that you want to write to. This is where you will put the read register. Okay. So you want to read from 40,001. Remember, there's always an offset of 1. So it will always be 0 that you would add in there. Okay. So then you open up the element screen, and then you add the function block. Okay. You basically add everything that I've added over there to the function block. Important thing is this connection number 3. That connection number 3 is a connection we set up when we were setting up the connections a little bit earlier. This remote IP address, it's in hex. So that remote IP address will be the actual IP address of the device that you're talking to at the end of the day. Okay, so if you break that up, it's 192.168.0.55. Okay. And then you add, then you add that block there. Okay. So once you've done that, you rebuild the block. And once you've rebuilt the block, that basically converts the whole program. It checks that your program is correct and that there are no sort of syntax errors in your program. If all goes well, then you can download this program. Okay, so you write to the PLC, you write normally the parameters and the program, and execute and yes to all. You're going to write all the parameters, you're going to write the whole program into the PLC. Okay. So that was that. Let me quickly show you the actual application of it. Okay. So like I said, project, new project. This is the setup of the slave device, by the way. As you can see there, I have the master and the slave devices pictures over there as they communicate with each other. Okay. So what I'm quickly going to do is we go and we give it an IP address, like I did before. So we'll always give it an IP address. Now this IP address I made 192.168.0.55. As I'll show you over there now. And then you go to external configuration again as well. And once you're in there, you will add, like I said earlier, you're going to add your Modbus-TCP, you're going to add your Modbus connection. So you're basically opening up that connection for a Modbus connection now. Close with reflect, and then you say check, and everything's fine. And exit. What I did is I added a quick little program in here. So there's the little program. It's just basically to create network data so that we can check if our network connections are actually working. Rebuild it, and that is your slave basically set up as quickly as that. Alright. So next step I go, I say write to PLC, and first check my connection. Connection's fine, and then I would download the program to the PLC, which takes a few seconds. So once that's done, the PLC is in there, then you need to reset the PLC. Okay, which I'll do a little bit later anyway. So now we're going to set up the master side of the PLC. Also a new program, same as before. And now starts the fun. Now we start creating the connection again. We go down to the Ethernet port again under the parameters. Give our device an IP address. This one I made 50 if I remember right. 192.0.50. And then I need to add the connections again as well, the external connections. First two connections I made was for Malsofts. That's for example if you want to have a SCADA connect to it. And then I created, oh, that's wrong. I think I added the wrong one over there. So you don't add the Modbus-TCP one, you add the active connection because it basically creates an open connection to it. My port is 5645, and then we are talking to their IP address, .55, with a local port number of 502. And if all goes well, you say close and reflect with reflecting, and everything is good. Check, no error, and apply. You have to say apply or else it doesn't accept the changes at all. So now the next thing we do is we go to the local variables. Okay. Basically copy and paste from somewhere else. It's a long list to actually type in. And now we're going to add our library. And that's the library that I spoke of earlier with all the function blocks. That's the library that you're going to download from the Mitsubishi website. So now, in order to make it usable for the program, I need to drag and drop that F function block to the left-hand pane, also where it says function block, and now I can actually start using those function blocks inside my program. So once that is done, now we are going to start adding our program. Like I said earlier, this is where we're going to tell the system how many registers we're going to write to and read to. So it's 10 and 10 over there, so we're going to write to 10 registers and read from 10 registers. And we add the next block. Over there we're going to tell you which registers we're going to write to, which will be the 40,001 registers and then the 40,020 registers. So that's why we add 19 in there. And now we add the function block. Add the function block. So once the function block is added, then we go through all that. Port 502, IP address, port number, very important. And then I'm going to tell it which registers I want it to write to. So for this example, I think I wrote doing my write registers from D0, and my read registers from D0, and my write registers are going to D200. The PLCs are unfortunately in the way there. So if everything has gone well, now we need to rebuild our program, where we basically convert the program, check for syntax errors like we did before with the slave device. So you go to the convert up top and rebuild all. Once that is built and done, it will check for the program is correct. Good thing is here everything is fine. Now we're going to write this to the PLC. So we go online, we check the connection. Connection test, which is good. So okay. And now we write the program to the PLC. This will take a few seconds. Before we can get it to communicate, we need to reset the PLCs. And your communications should start working immediately. As you can see over there, those lights flashing basically tell me that the program is working, that the communications is working. That was that little count up that I did in the slave device. So the slave device is the one on the left and the master device is the one on the right. Now let's quickly monitor. Go to I think it was D0, and those addresses that you see there, D0 and D9, those are the ones that we are reading in the master PLC from the slave PLC. That's how I know that the system is working. So that was successful. There you go. And that's basically all I wanted to show you guys. So let's see, guys. Thank you for listening. Thank you for tuning in. Do you guys have any questions for me? If you guys don't have questions for me, then I'll be signing off. I want to say thank you very, very much for joining me. I apologize about the sound issues we had a little bit earlier. New setup and all, but that's no excuse. Thanks for listening, guys. Please like and subscribe to our page. Like this video, subscribe, click on that bell icon as it shows you over there, so that every time we have a video uploaded, or that you'll be able to know that the video has come through. The next video session, I think, is on Tuesday, and if I'm not mistaken, it's about OEE. I'll be joining you guys next Thursday again at 11 o'clock at the same time, where we will be setting up a connection between a Mitsubishi PLC, iQF PLC, and a VSD drive. We'll be using Modbus RTU for that. Okay, so today I showed you Modbus-TCP, which is the Ethernet standard. Next week I'll be showing you the simple serial standard. Okay. And I want to thank you guys. I'll see you guys next week. Thank you for tuning in.